Let's see how magic method new works. And we have discussed how init works. Init is an initializer that will be called when we wanted to initialize some data during instantiation. For suppose here where so I'm initializing. We have also seen how method overriding works, because if you define init here, the init from the parent won't be called, because that is it shadows the parent init method. This is called a method overriding. So when I actually pass this some if I run this thing for suppose Python 3 and magic, if I run this thing, you see there is actually branch is a Melbourne, SID is none, is teaching is none. If I set SID here, mark.sid, okay, so I can put something mark dot is teaching true. I can set those details. If I run this, now you can see that student ID, sorry, staff ID. But I don't want to actually, so for each instance I create, I would have to set something like this. So if I actually, so I would have to set something like this, instead of doing that. So what if I'm able to pass those default parameters for the object, where those parameters make that each object unique, where I can pass staff ID equal to something, okay, something like this. But thing is that if I pass that, and I'll get an error. Why? Because when if I run this thing, I'm getting an error. Init got unexpected keyword argument, right? Why? Because which init is getting called, this init. Okay. So since when you instantiate, when you create an instance, when you call the function, the arguments you pass, they are received by init method. Okay, because it is an initializer. So why it is called initializer? It initializes the object or an instance. So with a given parameters. So staff ID. Okay. So what I'm doing here, I'm initializing. Okay. Where self dot staff ID. What is that? We don't have staff ID. SID we have. Okay. Staff ID. Got it? So if I run this thing again, so you can see this SID is whatever I have passed here. Got it? So likewise, I can create another instance. So we have print mark. Okay. So Peter we have to change this ID. So I run this thing. You can see here Peter. For a Peter also, we haven't called for Peter print details, right? Peter print details. And you see, as you can see here, which is a SID for Mark is different, SID for Peter is different, and these objects are different. Can you see here for the Peter, which is 93 something, whatever we pass here, for Mark, which is different. So each instance has a different data, right? So that data is each instance has a different data. So we are initializing each instance with the arguments we are passing, that it is taking a parameters and initializing the instance that is created with the parameters it received. Got it? So that is correct. So that is what we call it as an initializer. Very, very advanced concept where we don't actually typically use this one. Define new, okay, where, okay, so we use the new method. New is used as a constructor. It is called when actual instance is created. Okay. Yes, all method, all takes a new takes a class one. Okay. Okay. New is different. Okay. So which is different from others, where new takes a class, not a self. Okay. So which in fact takes less and creating instance. The way basically new should return an instance. Okay. So whatever is new returns, that will be a return value here. Okay. So by default, if you don't define anything, so default by default Python actually calls a default one. Got it? So let's call this thing here creating instance. If I don't actually return anything, oh, oh, I haven't saved. Okay, you see none type object has no attribute print details. Why? Because it is returning nothing new. New is not returning anything. So how it works is quite advanced. Okay, where do you use really new? You don't have to really use new. Okay, because Python takes care of it. When you wanted to customize object creation, okay, where when you are writing some libraries or frameworks, when you wanted to create some uh when you wanted to create object creation, that is when you wanted to really use a new. Okay, so if I return 3 here, for suppose just imagine if I 3 here. Okay, so I'm printing mark here. Can you see? Let's I'll comment this thing. Okay, and execute this. Well, you can see here id of mark, what I'm getting here 3. Okay, why just it's not id, just a value. Okay, what I'm getting 3. That is what it is. If you can see, the initializer is not at called. Can you see? So what is the process? First, the new method will be called to create an instance, and the instance that is created on top of that instance, this init will be called. Okay, you can see here the creating instance is called, and after creating instance, and we don't get a chance, Python didn't get a chance to call this init because we returned something else 3. That is what we can see here. So that is what, because since we returned a 3, which is an integer, that is what we see here. Integer object has no attribute, print details. So what is the responsibility of a new magic method? It is simply calls its responsibility is to create a new object and return that. Okay, so this thing we can actually also do. There are multiple ways to create object. This object is called a parent. Okay, which is topmost in a inheritance chain hierarchy in a Python. Object is a parent. Okay, so parent object is a object of all. Okay, so if any class you define is not inheriting any from anything, by default it inherits from object. Okay, for suppose if I take a Python 3, okay, go to interpreter, the class foo pass. Okay, so I can create a foo dot. This is a magic method. The basis magic attribute is a basis, is a magic attribute which returns what are the bases, what are the base classes. Means what are the base classes from which this class is getting inherited? They are actually so returned as a list. You can see object which is actually default one. So any class that is not inheriting from anything, that inherits by default from object, which is a parent object. Okay, topmost master or parent, topmost parent, you can call whatever you want. So which is actually topmost object in the hierarchy. Okay, by default. So if you don't inherit from anything, you are inheriting from object by default in Python. So I'm calling what I'm calling. I'm just calling that. So creating object and return. So with this, what I'm doing, I'm just, this also has a new method. Creating object one way is actually I'm returning that. So manually, I'm doing this whole stuff actually to do manually. Okay. When you really wanted to use this new, you really don't want to use that. Okay. So unless you wanted to do some customization with object creation. Okay. So when you are writing libraries or frameworks, or especially you have a particular use case for your project, for your work. You can see here now it's working as usual because whatever I did here. So I did that I did that. What this Python is, Python does this thing implicitly. What I did. If you don't provide anything, what I did, I manually created object and returned that object. Now after creating object, you can see that initializer is getting called. Can you see? Okay. So you can wonder one thing, if you don't actually, if you have this initial new method here, you remove this thing here, and if you that in a super, grandparent, okay, this is just a parent here, and this is a grandparent for a tutor, okay. So even though if I put that thing there, new will be called. Can you see creating instance, right? So because it is checking if new is available in this tutor, if not, it goes and it will check in a parent if it is available, and if not, actually in a grandparent or great great grandparent. Okay, it will check there. If nowhere it is available, okay, it does Python by default actually uses uh, the internally and creates the object. Okay, so do you understand? Ah, so no, new this for any method. Okay, if method is, that is a method resolution order. Okay, so that is called method, how that is how methods are resolved. And this method you can actually do some custom here. And so whatever want, in such a case you really wanted to use a new. And there is actually type function in Python where yes, type is used to convert types. So not to convert types, to print types. Remember, there's a type function. If you simply call type of or anything, it will just yes, yes, and it has a two signatures. Okay, one is a type. It will simply return with one argument. It will return what type it is. So suppose if I go to Python 3, type of 9, which is integer. Okay, the class foo, if I return, not putting anything, type of, okay, and so I can actually give a name foo, okay, and the base inherit, let's inherit bar, let's inherit this thing from foo, and local attributes. Okay, dict represents attributes. If I pass like this, I'm creating runtime. I'm creating call something called a class or object runtime. Okay, you can see here I created a bar. Okay, probably I don't to avoid confusion, I can put something here, something called XR. So print XR, which will be bar because the name I have given. XR dot basis. You see it is inheriting from foo. Okay, so what is this? This is a here you go. There's a type. You can see here there are two signatures for especially for the type. If we pass one, it returns type of that object. And if you pass, you can choose to pass three different or four different arguments. This is a variable and keyword arguments. Last one, and by doing so, you can create on fly runtime. You can create a class or object or anything. Okay, do you understand? Uh, So the same thing, instead of actually doing so calling this, I can also use type here. Type of what is the name. I can use cls dot name. Okay. You can see here who dot name is a magic attribute which represents a name. Okay, the class by default I'm receiving reference to the class. I can uh, there are no bases, or I can put some bases here. Okay, which is a teaching staff I'm inheriting from. And then though no attributes, these are this dict represents. You can see here there's some documentation which represents basically which is an attribute. So which becomes a dict attribute which represents attributes of a class. Okay? Where you can see if I do class to x equal to 9, y equal to 2, foo dot, surprisingly what dict does. You can see here there is x and y. So all attributes of that particular class or object can be accessed through dictionary under dict magic method. So if I create x equal to foo instance and x underscore underscore dict, you can see it is having nothing. But if I still access x dot x, x dot y, works because those attributes are, remember we discussed again, those are called the shared attributes across instances, because class attributes are shared across instances. And if I put something here, x dot 9, x dot z equal to uh, 76, and x dot dict, and you can see here though that thing access the that those attributes are available as a uh, added into dict magic method, magic attribute. So that way I can choose to pass those attributes as a dictionary. So now if I run this thing also, it works. It is working as usual. You can see. So thing is that we don't have to do that. The whole goal is actually we are discussing how this magic method works. New magic method works, which is actually the constructor. Okay, new if you understand, where is print details? Yes, okay, so this is what it does. And another thing, another important most important thing is, again I said you really don't want to work with don't need to work with this new magic method. You really don't need to. You don't have to. Python takes care of it. But whenever you wanted to do some magic with the object creation, that is when you wanted to use. But if you create these instance something like this, you end up actually having it. There is actually uh, caveat here, so you may end up creating a recursion loop. Okay, so that is what it is. And so what I written here is a object, and if I actually print what is the type of mark here. Why? Because since I am calling this object, it is calling object creation new again. And inside that, I created object and calling a new again, so that you can see here the recursion loop. And here, so what by doing so, what we have written here, we created a class. Okay, so instead of doing so, we want a real object obj equal to obj dot new, or a super new. Okay, and return object. And it is taking some arguments. If you know what are those arguments, the student ID, right? So for the time being, I'm using that something random here. I'm giving. Oh, okay, yeah, there you go. So sorry, we should not give that this argument here, student ID. We should pass, since the first argument new takes is a class. Uh, that is what we are supposed to pass. Okay, so since as we are passing this, and you can see that everything works as usual. So this is about new magic method. So new magic method, when new magic method is the actual constructor, and after that initializer init method is used, and we always are you know we may not actually create any class without initializer, because we want to initialize the instance. But new magic method is it's like really don't want to use in actual work, which like a black swan. Okay, of course you really want to when it comes to, if you have a requirement, if you take an example of Django, how it is written internally, so it chooses meta classes and this new magic method to create a ORM, object relational mapping. This is a very advanced concept. So what is the difference? New method is used to create a object or instance, that is actual constructor, where init is actually initializer, which is used to initialize a created instance.